let's talk about three different types of reactions. The first one is the combustion reaction. And this is the sort of reaction that we were talking about with burning fossil fuels. In a combustion reaction, we've got the reaction of a substance with oxygen. And it's going to form one or more oxygen-containing compounds. Often that's water. Let's highlight a couple of things here. Reacting with oxygen, and these reactions emit heat. Why do we burn natural gas in a Bunsen burner? Because we need to make something warmer, right? Because the combustion of natural gas gives off a lot of heat. We do that in your gas stove at home, right? To heat up the water so you can make spaghetti. So there are lots of different combustion reactions. The only one that we're going to really look at is when we're burning compounds containing carbon, hydrogen, and oxygen. Any compounds containing just carbon and hydrogen or carbon, hydrogen, and oxygen, the products are always going to be the same. So it doesn't matter what the reactant is, it's going to react with oxygen, and it's going to form CO2 and water. Natural gas, methane, reacts with oxygen to form CO2 and water. Now, CO2 is something that we're a little concerned about because of, the increased CO2 in the air and stuff, and we're thinking probably related to global warming. We're not sure. Please, Mr. Troll, don't comment on this one also. Mm-hmm. But is carbon dioxide super toxic? No. What is coming out of your nose as you're breathing? Carbon dioxide. Are we all dead in here? No, we're just fine.
I'm dead inside.
I'm dead inside. You've killed my spirit with chemistry. But CO2 is not considered a harmful chemical, right? H2O, is that harmful? No. The thing is, if you have too much of it, it is, right? Too much of anything is going to be harmful. But a little bit of CO2, a little bit of H2O, this is not bad stuff that's coming out of this combustion. So the carbon dioxide is a concern. But what about all that other pollution that we're getting from gasoline-powered vehicles? Well, that's because what we're burning is not pure hydrocarbons. It's not just octane, or octane and nonane and decane. It's got other stuff in there because it came from this big stew of petroleum product, and they refined it and they pull different sections out. Could you refine it into pure octane? Sure you could. But then it would be so expensive that no one could afford to use it. So there's this compromise, right? So they refine it enough that it's not going to cause a big problem when you burn it in your car, but not so much that it's too expensive. Now, you could say that it's too expensive as it is, and I agree. My daughter went and got gas, and she was like, oh. I'm like, yeah, honey, that's how it is. Welcome to the real world. We should be able to write balanced chemical equations for combustion reactions of things containing carbon, hydrogen, and oxygen. So you will be told what is going to burn. So here, this happens to be the chemical formula for ethanol. So write a balanced equation for the complete combustion of liquid C2H5OH. That's ethanol. And the reason it's written a little funny here with this hydrogen separated from the others is this OH, that's the alcohol functional group we mentioned when we were talking about organic compounds. So they're telling us it's a liquid. In a combustion reaction, what's the other reactant? Oxygen. Oxygen is a diatomic element, so it's O2. It's a gas. What are their products? Carbon dioxide and water. What state should we give for water? Gas. Water is a liquid at room temperature, but when we're burning something, this is not happening at room temperature. It's going to be hot. So that's why the water's in the gas state. I won't try to trick you with that, but it is what it is. Okay, so there's our skeletal equation. Now we need to balance it. Let's just start at the beginning. I have 2 carbons on the left. Over here I only have 1, so I'll put a 2 in front of that molecule. So I've got 2 carbons on each side. Hydrogens, need to be a little bit careful here. There's 5 here and 1 there, so a total of 6. Over here I have 2. What do I need to multiply that by? 3. Now I have 6 hydrogens on each side. Now there's oxygen in everything here, right? So let's be careful. So I have 1 oxygen there, and I have 2 oxygens here, but I can multiply that by something. How many oxygens in this guy? 4. And in 3 water molecules? 3. So 4 plus 3 is 7. So over here, this needs to add up to 7. At first, this might look like we've got an odd-even problem, but there's 1 oxygen over here, so that means what I need here is an even number, and so we're spared all the multiplying by 2. So if I put a 3 in there, then I'll get my 7. Any questions? Another type of chemical reaction is the alkali metal reactions. They react vigorously with nonmetals. And their reactions are going to take this form. A metal is going to react with a halogen, that's fluorine, chlorine, bromine, iodine, those guys, and form a metal halide. So the metal with whatever halogen it is. So if we look at this one here, we've got sodium and chlorine. Sodium is an alkali metal, it's in group 1. Chlorine is a halogen, it's in group 7A. And so to predict what the product is, these are going to be ionic compounds, a metal and a nonmetal. So we're just going to look at the charges, and this is the same as answering the question, what is the formula for the compound formed between sodium and chlorine? Well, sodium makes a +1 ion because it's in group 1, right? And chlorine makes a -1 ion because it's 1 to the left of the noble gases. And so then that's going to give me NaCl. And then you write that in here, and then you have to balance it. There's 2 chlorines here, so I need a 2 here, and that means I need a 2 over there. As you go down in that family of alkali metals, the reactions get more and more vigorous. Alkali metals also react with water. And when they do this, they form hydrogen gas. So here we have photographs of lithium reacting with water, sodium reacting with water, and potassium reacting with water. And this one's, fizzing and putting off hydrogen gas. This one's also making hydrogen gas, but it's making enough, it's giving off enough energy that it ignites the hydrogen gas, so it burns. And then the potassium is like shooting sparks out. Halogens are reactive nonmetals. This picture shows us the elements. This is chlorine, which is kind of a greenish gas at room temperature. Bromine is a liquid at room temperature. The liquid is really like a dark brown. And then here, some of it has evaporated into the gas state. It's kind of an orangish gas. And then iodine is a solid at room temperature, but it sublimes like dry ice does. It'll go directly from the solid state into the gas state and makes this really pretty purple gas. So halogens can react with many metals, not just the alkali metals. And this is a general form of their reactions. So the metal plus the halogen to make this metal halide. And again, to predict this product and to balance the equations, we're just going to look at the charge on the metal ion and the charge on the halide ion and put the formula for the product in and balance the equation. I think this makes it look more complicated than it really is. Halogens also react with hydrogen, and they do that to form hydrogen halides. So like H2, let's do this. H2 gas plus chlorine gas is going to make 2 HCl gas. Does HCl look familiar? Hydrochloric acid? Here it's in its gas state because it's not dissolved in water yet. But predicting these formulas, again, we're just looking at the charge that a hydrogen ion has and the charge that the chloride ion has. Halogens can also react with each other. Okay. Write a balanced chemical equation for each reaction. I remember finding these very frightening as an undergrad. What do you mean? Write the whole equation? I don't know what that makes. Well, I'm only going to ask you ones that are rather straightforward. So let's not freak out. Let's just think about it. The reaction between aluminum metal and chlorine gas. Okay, well, let's write down those formulas. Aluminum metal, is it a solid, a liquid, or a gas? It's a solid. And chlorine gas, what's the formula for chlorine? Cl2 gas. So those are going to react, and what are they going to form? I don't know. Well, what are the ions? What charge does aluminum have? Close. +3. Groups 1A, 2A, 3A, zinc and silver. 1A, 1 plus. 2A, 2 plus. 3A, 3 plus. And then chloride is -1, right? So how do we put those together? Well, I need 3 of the chlorides, right? So that I have a -3 charge from those guys and a +3 from that guy. So that tells me that the formula for this product is AlCl3. Ionic compounds have very high melting points. So, I mean, most of them behave a lot like table salt. So, salt is an ionic compound. What is its state at room temperature? It's a solid. Again, I wouldn't try to trick you on that. How do we balance this? We'll start at the beginning. 1 aluminum, 1 aluminum. Awesome. 2 chlorines, 3 chlorines. I have an odd number on one side and an even number on the other side. If I multiply by 2, I can make my odd number into an even number. But if I do that, now I've messed up my aluminums, so I better go over here and put a 2 in front of aluminum. Now I have 6 chlorines over here, so if I have 3 chlorines over there, I balance chemical equation. I don't like that one, we're not going to do it. Any questions about A? The reaction between gaseous hydrogen and liquid bromine. Again, let's just start by writing down things that we know and see if we can figure it out. Well, what's the formula for hydrogen? H2, and that's a gas. What's the formula for bromine? Br2, and they tell us that's a liquid. Okay, there's my reactants. Well, we can predict the charges, we can predict the product here by looking at ion charges. Because even though HBr is not an ionic compound, when it dissolves in water, it becomes ions. So I need 1 hydrogen for each bromine. I would not expect you to know that that's a gas, but you should be able to balance it. What do I need?
2 hydrogen.
I needed 2 in front of the HBr. Yeah, there we go.